Can anyone, how do you define probability? What is probability? What is probability? Can anyone define it in your own perception? How do you define probability? What is probability? How do you define it? Can anyone? In your own perception, what is probability? How do you define probability?
Yes. Is it like the different possibilities of a certain situation?
Okay, uncertain and certain situation. What else? What else? What else? Anyone? What is your insight when you heard the word probability? What is your
What's the
insight?
number of how likely it is to happen?
Okay, how likely it will able to happen. So that's probability. Okay, so all of your answers are correct in defining probability. But what is probability? Okay. So the definitions of probability. Okay, a probability experiment is a chance process that leads to well-defined results called outcomes. Okay, a probability experiment is a chance process that leads to well-defined result called outcomes. Okay, so what is the example of probability experiment? Okay, again, you said a while ago, we say probability defined as the uncertainty and certainty of an event. Okay, so when we say probability experiment, it's a chance process that leads to well-defined result called outcomes. Okay, so you do have science experiment. Okay, of course, in probability stat, we do have probability experiment. And what are those? So the example of that one will be flipping a coin, rolling a die, drawing a card from deck. So that will be the example of probability experiment. Okay, the result of that one, that experiment, we call it outcomes. Okay? An outcome is the result of a single trial, okay, of a probability experiment. An outcome is the result of a single trial of a probability experiment. Example of that one, okay, example of outcome, when a coin is tossed, there are two possible outcomes. And what are those? And that will be head or tail. Okay? So what's an example of outcome? Example of that one, when a coin is tossed, there are two possible results, or there are two possible outcomes. And what are those? It can be tail or it can be head. Okay? So that is an outcome. Okay? What about sample space? So when we say sample space, is the set of all possible outcomes of a probability experiment. Okay, a sample space is the set of all possible outcomes of a probability experiment. What about tree diagram? I think we have it last time. Okay, so when we say tree diagram, it's a device consisting of a line segments emanating from a starting point and also from the outcome point. It is used to determine all possible outcomes of a probability experiment. Okay, we have that when we're discussing permutation or counting of fundamental counting techniques, the tree diagram. Okay, so tree diagram, how do we use it? Okay, so for example, use a tree diagram to find the sample space for the gender of 3 children in a family. Okay, so how do we use tree diagram in finding the sample space for the gender of 3 children in a family? Okay, so you do have starting point. Okay, so children, so we have first child, second child, and then the third child. Okay, for the first child, you do have two outcomes. Okay, it can be a boy or it can be a girl. And then for the second child, so same thing. Okay, you do have two outcomes. Let's say the first child is a boy, and then the second child, it can be boy or girl. And then the third child, it can be boy or a girl also. Okay, so that is a tree diagram. Okay, so tree diagram. So after we come up with a tree diagram, okay, with the example that we have a while ago, so what are the outcomes? Okay, so these are the outcomes. So it can be 3 boys. Okay, the children can be composed of 3 boys. Okay, or it can be 2 boys and then 1 girl. That's the second outcome. The third outcome or the third result, it can be boy will be the first child. The second child is a girl, and then the third child is a boy. Okay, and then the fourth outcome, the first child is a boy. The second and then the third are both girls. Okay, and then the fifth outcome, the first child is a girl, and then the second and third are both boys. Okay, then the sixth, we have girl, boy, girl. Next, girls, 2 girls, first and second, and then the third is a boy. And then the last outcome will be all of them are girls. So that are outcomes. Okay? So how many outcomes do we have? How many? How many outcomes do we have? So 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay? Next. Okay. So definition of terms, what about event? What do you mean by event? An event consists of a set of outcomes of a probability experiment. It could be one outcome or more than one outcomes. Okay? So what do you mean by event? An event consists of a set of outcomes of a probability experiment. It could be one outcome or more than one outcomes. So what is an example of event? The event of getting an odd number when a die is rolled. Okay? The event of getting an odd number when a die is rolled. Okay? So that is an example of event. Probability can be classified into three. So we do have classical probability. The second is empirical or relative frequency probability. And then the third is subjective probability. Okay? So what is classical probability? What do you mean by that one? When we say classical probability, uses sample spaces to determine the numerical probability that an event will happen. Okay? Again, let's proceed on to the first classification or the first type of probability, and that will be classical probability. But how do we define it? When we say classical probability uses sample spaces to determine the numerical probability that an event will happen. Okay? So first type of probability studied formally by mathematicians in the 7th and 18th centuries. Assume that all outcomes in the sample space are equally likely to occur. Okay, what do you mean by occur? Happen. Okay, assumes that all outcomes in the sample space are equally likely to occur. Okay, so how do we apply classical probability? So the probability of any event E is the number of outcomes in event over the total number of outcomes in the sample space. Okay, that's how we use classical probability. Okay, the number of outcomes in an event over the total number of outcomes in sample space. So this probability is denoted by the probability of an event is equal to the number of outcomes in the event all over the total number of outcomes in the sample space. Okay, so for example, let's say let's try to analyze example number 1. Find the probability of getting a black 10 when drawing a card from a deck. Find the probability of getting a black 10 when drawing a card from a deck. Okay? So how many black 10? How many? There are 2. Okay, there are 2. There are 2 black 10. But how many cards do we have in a deck?
52.
Okay, 52. So there are 2 black 10. Okay? So there are 2 black 10. So there are 2 black 10 out of 52 deck of cards. Okay, out of 52 cards. So that will become 1 over 26. How do you get 1 over 26? The question is, how do you get 1 over 26? Simplify 2 over
56.
2 over 52. So that will become 1 over 26. Okay? 1 over 26. Next, what about this one? If a family has 3 children, find the probability that the 2 of the children are girls. If a family has 3 children, find the probability that the 2 of the children are girls. So how do we answer this one? We have this before, okay? The tree diagram of the 3 children. But the question in number 2 is, what's the question? Find the probability that the 2 of the children are girls. Okay? So going back to the tree diagram that we have a while ago, okay? So this is the tree diagram of the 3 children. Okay, so how many, what is the probability of what? The question is, what is the probability that the 2 of the children are girls? That the 2 of the children are girls. So based on the tree diagram that we have, okay, how many out of 8 outcomes, okay, how many composed of 2 girls? How many? Based on the tree diagram that we have, how many composed of 2 girls? You count, how many? How many?
1.
The 3 children composed of 2 girls. Ilan daw yon? How many? How many of those? Based on the tree diagram that we have.
2.
Is it 2 only?
3 po.
Okay, 3. What are those? What are those? The first one is?
BGG.
Okay, B, G, G, G. The second?
GBG.
Okay, the third? Okay. 3 out of how many outcomes? 3 out of how many outcomes?
8.
Okay, 8. So therefore, in number 2, okay, so in number 2, find the probability that the 2 of the children are girls. So the answer is 3 out of 8. Okay, 3 out of 8. Okay, next. So classical probability, we have 4 basic probability rules. Okay, so number 1, the probability of any event E is a number, okay, either a fraction or decimal, between them including 0 and 1. Okay, this is denoted as the probability of an event is greater than equal to 0 but less than equal to 1. Okay, that's why your answer can be fractions or decimal. Okay, if an event E cannot occur, the event contains no members in the sample space, so its probability is 0. Again, if an event E cannot occur or it will not happen, so the example of that one, the event contains no members in the sample space, so its probability is 0. Okay. The third, if an event E is certain, then the probability of E is 1. Okay. What do you mean by certain? Meaning it will happen. So the probability is 1. Okay. Number 4, the sum of the probabilities of all outcomes in the sample space is 1. In short, or in other words, that the highest number in probability is 1, and then the lowest is 0. Okay? So complement of an event E denoted by E bar, or in some books, okay, we use it E prime. Okay? Complement. What do you mean by complement of an event? Meaning it won't happen. So the probability that it won't happen, we can use this one, this symbol, denoted this symbol, okay? The probability that it won't happen, it can be E prime or E bar, okay? You can use both, E bar or E prime, okay? So when we say E bar or E prime, meaning it won't happen, or simply we call it complement of an event. When we say complement of an event, it won't happen. The set of all outcomes in the sample space that are not included in the outcome of an event E. Okay? So the rule of complementary events. Okay? So the rule of the complementary events. Okay? When we say complementary events or it won't happen. Okay? So the probability it won't happen, that will be equal to 1 minus the probability it will happen. Okay? But remember people, probability it will happen plus the probability it won't happen, that will be equal to 1. Okay, so try to remember this basic rule. Okay, so the probability will happen plus the probability it won't happen, that will be equal to 1. Okay, and then the probability it will happen, that will be equal to 1 minus the probability it won't happen. Okay, so try to remember the rules for the complementary events. Again, when we say complementary events, meaning it won't happen. The event will not occur. Okay, it will not happen. Okay, so for example, number 3, if the probability that a person lives in an industrialized country of the world is 1 over 5, okay, the probability that the person live is 1 over 5, okay, find the probability that the person doesn't, okay, the person doesn't live in an industrialized country. So how do we answer that one? Okay, number 3, if the probability that the person lives in an industrialized country of the world is 1 over 5, so how do we solve, or how do we find the probability that the person, okay, that the person does not live in an industrialized country? Okay, so how do we answer that one? Using the complementary events. How do we answer that one? Find the probability that the person does not live in an industrialized country. The only given is that the probability that the person lives in industrialized country, which is 1 over 5. So how do we solve, or how do we find the probability that person does not live using the complementary event? So how do we solve it? How do we solve it?
Just subtract 1 to 1 over 5.
Okay, so that will be the probability that a person does not live, okay, in an industrialized country. So that will be 1 minus the probability that the person live in that country. So that will be 1 minus 1 over 5, which is equal to what? Which is equal to what? 1 minus. Okay, 4 over 5. That's very good. Okay, that's good. Next, what about empirical? Let's proceed to the second type, and that is empirical probability. When on the actual experience to determine the likelihood of outcomes. Okay, again, The second type of probability, which is empirical probability, relies on actual experience to determine the likelihood of outcomes. Okay? So what's the formula for empirical probability? So given a frequency distribution, the probability of an event being in a given class is, okay, the probability of event is equal to frequency for the class, okay, denoted by F, over the total frequencies in the distribution, which is denoted by N. Okay, so it's the formula for empirical probability. F over N. Again, what is F? When we say F, frequency for the class over the total frequencies in the distribution. Okay, this probability is also called empirical probability, and it's based on observation. Okay, so when we say empirical probability, this probability is based on your observation. Okay, so what is the example? Okay, here, example number 4. In a sample of 50 people, okay, take note of this. 21 had type O blood. 22 had type A blood. 5 had type B blood. And 2 had type AB blood. Okay, set up a frequency distribution and find the following probabilities. Again, when we say empirical probability, you base your probability on observation. Okay, so find the probability a person has type O blood. How do we answer that one? A person has type O blood. How do we find the probability? Again, using the empirical probability, what's the formula? Number of frequencies for a class over the total number of frequencies. So how do we answer letter A? A person has type O blood. How do we answer it? A person has type O blood. How many type O blood based on the example that we have? How many?
It's 21.
Okay, 21. But how many sample people?
50 po.
Okay, 50. So what will be the answer?
21 over 50.
Okay, 21 over 50. That's correct. Next, a person has type A or type B blood. When we say or, what is the operation? There's a word or.
Addition po.
Okay, addition. So how do we find the probability of a person has type A or type B blood?
22 plus 5 po.
22 plus? 22 plus?
22 plus 5 po.
Okay, so what will be the answer?
27 over 50.
Okay, 27 over 50. That's correct. Next, letter C. A person has neither type A nor type O blood. What do you mean by neither? What do you mean by neither? What do you mean by neither? Meaning?
Excluded po.
Okay, so what will be the answer in letter C? Meaning they are not type A nor type O.
7 po.
Okay, 7. How do you get 7?
Miss, there are 5 type B and 2 type AB.
Okay, so what will be the answer in letter C?
7 over 50 po.
Okay, 7 over 50. Next, letter D. A person does not have type AB blood. A person does not have type AB blood. A person does not have type AB blood. Meaning that person is not a type AB blood. So what would be the probability that person is not a type AB blood? So what would be the answer?
48 over 50.
Okay, 48 over 50. Can we still simplify 48 over 50? Can we still simplify 48 over 50?
24 over 25.
Okay, 24 over 25. Okay, 24 over 25. So that's empirical probability. You base your probability on your observation. Okay. Next, number 5. The following information shows that the amount of debt students who graduated from college incur. Okay. So we have $1 to $5,000. So you do have 27%. And then $5,001 to $20,000. That will be 40%. 20,001 to 50,000, that will be 19%, and then $50,000, that will be 40%. If a person who graduates has some debt, find the probability that it is less than $5,001. It is less than $5,001. So what will be the answer in letter A? Based on the table that we have, find the probability that it is less than $5,001. So what will be the answer in letter A?
Was it 27%?
Okay, 27%. Next, letter B. It is more than $20,000. More than $20,000.
33%.
33%. How do you get 33%?
19 plus 14%.
Okay, 19 plus 14 because it says more than $20,000. Next, it's between $1 up to $20,000. $1 and $20,000. It's between $1 up to $20,000. So what will be the answer?
67.
Sorry?
67.
Okay, 67%. How do you get that?
40 plus 27.
Okay, next. It is more than $50,000. More than $50,000?
14%.
Okay, 14%. Okay, so that's the use of empirical probability. Okay, next, what about subjective? Okay, so the third type of probability, subjective probability. Okay, any idea what is subjective from the word itself? What is subjective? Any idea? What is subjective? Any idea what is
Pili
subjective?
lang po.
Yes.
Pili lang po yung example, yung sample.
Okay. Okay. I get your point. Another. What do you mean by subjective? Probability. You base your probability on what? On what?
On an individual po.
Okay. Let's see. So when we say subjective probability, uses a probability value based on an educated guess or estimate. Okay, that's correct. The one you answered a while ago. Employing opinions and inexact information. So that is subjective. Okay. So you base your probability value on educated guess or estimate, employing opinions, and inexact information. So what are the example of subjective probability? So this guess is based on the person's experience and evaluation of a solution. So the example of that, a physician might say that on the basis of her diagnosis, there is a 30% chance that the patient will need an operation. Okay? So you base your answer on your experience or evaluation of solutions. Okay? Of course, a physician, they will base their evaluation based on their diagnosis. Okay? So that is subjective probability. Okay? Experience, opinions. So we get your value, okay, your probability value based on educated guess, estimate, opinions, or inexact information. So that is subjective. Okay? Seismologists might say there is an 80% probability that an earthquake will occur in a certain area. Okay? Based on their evaluation, based on the flow or the movement, okay, they can give their they can give their probability. Okay? So seismologists might say that there are 80% chance that an earthquake will occur, okay, based on their evaluation, based on their experience, based on their opinions. Okay, so that's subjective probability. Okay, when we say probability, chances, a certainty or certainty of an event. Okay. So there are two events are mutually exclusive if they cannot occur at the same time. Okay, two events are mutually exclusive if they cannot occur at the same time. Okay, they have no outcomes in common, meaning there's no common point. Okay, when two events A and B are mutually exclusive, the probability that A or B will occur is the probability of A or B is equal to the probability of A plus the probability of B. So we call it addition rule. Okay, if A and B are not mutually exclusive, then the probability that A or B will occur is the probability of A or B is equal to the probability of A plus the probability of B minus their common point. Okay, the probability of A and B. So what is the difference between mutually exclusive and not mutually exclusive? When we say mutually exclusive, meaning there's no common point. But when we say not mutually exclusive, there is a common point. So that's the difference between the two. Okay, so for example, okay, a certain city has 9 coffee shops, 3 Starbucks, 2 Figaro, and 4 Seattle's Best. If a person selects one shop at random to buy a cup of coffee, find the probability that it is either Starbucks or Seattle's Best. How do we answer number 6? Find the probability that is either Starbucks or Seattle's Best. Again, when we say or, you're pertaining to what operation? It's addition. Okay? So in this particular example, is it mutually or not mutually? Is it mutually or not mutually exclusive?
Mutually po.
Mutually. Why is it mutually? That's correct. Why is it mutually?
Just because it says either or, so addition po yung gagamitin.
Mm-hmm. So mutually because there's no common point, right? Walang common. So that is mutually, right? So what is the probability of it's either Starbucks or Seattle's Best? How do we answer that one? How do we answer that one? Any idea how do we answer that one? Number 6, how do we answer it? Find the probability that is either Starbucks or Seattle's Best. So a person, so what's the probability that the person select Starbucks? What's the probability?
3/9 po.
Okay, 3/9 plus the probability that the person selects Seattle's Best.
4/9.
Okay, 4/9. So therefore, what is the answer?
7/9.
Okay, 7/9. That's correct. Okay, so it's a mutually exclusive because there's no common point. So that the answer is 7/9. Okay, next, what about number 7? The corporate research and development centers for the 3 local companies have the following number of employees. Okay, US Steel has 110 employees. Okay, Alcoa have 750 employees. Bayer Material Science, they have 250 employees. If a research employee is selected at random, find the probability that the employee is employed by US Steel or Alcoa. What is the unknown? We need to look for the probability that the employee is employed by US Steel or Alcoa. So there's a word or again, meaning it's addition. Okay? But the question is it mutually or not mutually? Is it mutually event or not mutually event? Which is which? Try to identify. Is it mutually or not mutually? Number 7 problem. Is it mutually or not mutually? Mutually or not mutually? When we say mutually,
Mutually po.
sorry?
Mutually.
Okay, mutually, because there is no common point. Okay? Meaning both sides, they can stand alone. There's no common point. So how do we answer number 7 problem? Find the probability that the employee is employed by US Steel or Alcoa.
Miss addition pa rin po.
Okay, addition. So how do we apply that? How do we apply that? What's the probability that they are employed in the US Steel? So there are 110 employees. Okay? Over how many employees? For the 3...
1,100 po.
Okay, 1,110. So the probability that they are employed in US Steel, that will be 110 over 1,110 plus the probability they are employed in a Alcoa company, that is 750 over 1,110. The question is, Miss, where do you get 1,110? Where do you get that? Where do you get that? 1,110.
It's the total po.
Okay, it's a total. Very good, it's a total. So therefore, what is the answer? What is the answer?
Miss 860 over 1,110 or 86 over 111.
Okay, very good. That's 86 over 111. You need to simplify, okay? So that is 86 over 111. Okay, next. Next, number 8. A single card is drawn at random from an ordinary deck. Find the probability that it's either an ace or a black card. Okay, I repeat the question in number 8. A single card is drawn at random from an ordinary deck. Find the probability that it is either an ace or a black card. In this particular example, since we're talking about or again, meaning it's addition, under the addition rules, okay, is it mutually or not mutually? Of course, you need to identify first the events. Is it mutually or not mutually?
Not mutually.
Okay, why is it not mutually? That's correct. Why is it not mutually?
Just because there is also aces in black cards.
Okay, very good. Meaning there's a common point. Okay, there's a common point. Okay, that's why we call it not mutually exclusive. Okay, so how do we answer this one? How do we answer it? What is the
Consider
probability?
4 aces.
Okay, 4 aces out of.
There 52 cards.
Okay, plus how many black cards?
There are 28 cards po. So minus 2 from the 4.
28 or 26?
Ay, 26.
Okay, 26 out of 52 minus.
2 po.
Why is it 2?
That's because the other 2 aces are color red and then the other 2 are color black.
Okay, what are those? Spade and
diamond po. Ay,
Spade and?
clover.
Okay, clover. So now minus 2. Okay, minus 2. 2 there is the common point. So therefore, what is the answer? Therefore, what's the answer, my dear?
30 over 52 po. Ay,
What's the answer? The
30
probability.
over 52 po, or 15 over 26.
Are you sure? You have common point. You need to subtract the common point. You said that the probability of getting ace is 4 over 52. Plus the probability of getting a black card, that would be 26 over 52. Minus their common point, which is 2 out of 52. Because there are 2 aces, which is colored black. Okay? So what would be the answer?
28 over 52 po, or 7 over 13.
Okay, 7 over 13. That's correct. That's very good. So 7 over 13. Okay? So 7 over 13. Okay, next. What about number 9? In a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. Okay, try to examine the problem. If a staff person is selected, find the probability that the subject is a nurse or a female. Or a male. I repeat, question number 9. In a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, find the probability that the subject is a nurse or a male. Again, there's a word or. First, we need to identify, is it mutually, let me say mutually exclusive, no common point? Not mutually, there is a common point. So in number 9, is it mutually? Not mutually. Number 9, mutually or not mutually?
Not what mutually.
Okay, not mutually. Why is it?
That's because a nurse can also be a male.
Okay, a nurse can be also male. So in this particular example, find the probability that the subject is a nurse or a male. So what's the probability what's the probability that it is a nurse? What's the probability that it's a nurse?
8 over 13 po.
Okay, 8 over 13 plus the probability in male.
3 over 13.
Okay, 3 over 13. You said that it is not mutually. So meaning there is a common point. So minus their common point. So what's the common point?
This one male.
Okay, 1 male out of 13 persons. So therefore, what is the answer?
Twelve over 13 po.
What's the answer?
11 over 13.
11 over 13? 11 over 13?
10 over 13 po.
That is 10 over 13. Okay? So 10 over 13. Okay? 10 over 13. Because 8 plus 3, that's 11 minus 1, so you do have 10 over 13. Okay? Next, multiplication rules. So we're done with addition rules. Let's proceed on to the multiplication rules. 2 events, A and B, are said to be independent events if the fact that A occurs does not affect the probability of B occurring. Okay? That's independent events. Okay? 2 events, A and B, are said to be independent events if the fact that A occurs does not affect the probability of B occurring. So example of that one, what's the example of independent events? Tossing a coin and then rolling a die. Okay? The 2 events, they can stand alone. So that's independent. Okay? Rolling a die and getting a getting a 6, so that is independent. And then rolling a second die and getting a 3. So that's independent. Meaning, does not affect the probability of the other. Okay? Drawing a card from a deck and getting a queen, replacing it, and drawing a second card and getting a queen. Okay? So that is independent events. Okay? Again, we say independent events if the fact that A occurs does not affect the probability of B occurring. Okay? So in other words, if you saw a word replacing, that is independent. Okay? Because it will not affect the other event. Okay? So that's independent event. So when the outcome of occurrences of the first event affects the outcome of occurrence of the second event in such a way that the probability is changed that event, we call it dependent events. Okay, dependent events, meaning the first event affects the second. So that is dependent events. Okay, so the example of that one, drawing a card from a deck, not replacing it, and then drawing a card again on the second time, okay, without replacing, so that is dependent. Okay, having a high grades and getting a scholarship, parking a no parking zone and getting a parking ticket, so that is dependent. Okay, of course, your scholarship will be based on your grades. Okay, so it will depend on your grades if you will have a scholarship. So that is dependent events. Again, we say dependent events. The first event affects the second. Okay. So this one, when two events are independent, so the probability of both occurring is the probability of A and B. Okay. So when you saw the word and, meaning it's multiplication. Okay. So the probability of A multiplied by the probability of B. When two events are dependent, the probability of both occurring is the probability of A and B is equal to the probability of A multiplied by the probability of B given A. Okay? The notation of the probability B given A means that the probability that event B occurs given that the event A has already occurred. So that's the meaning of that notation. Okay? The notation of the probability B given A means the probability that event B occurs given that that event A has already occurred. Okay? So for example, a coin is flipped and a die is rolled. Obviously, it's independent events, okay, because they are different. They can stand alone. Okay? The first event is a coin is flipped and then a die is rolled. Okay? Find the probability of getting ahead on the coin and a 4 on the die. So how do we answer that one? So we need to get the probability of getting ahead and 4 and a 4 on the die. Okay? So what is the probability of getting ahead on a coin? What's the probability of getting ahead on a coin? What's the probability of getting... Okay, 1 over 2. Okay? Because a coin has two faces, and that will be head and tail. So you do have 1 over 2. So since there's a word and, meaning it's multiplication, multiply it. What is the probability of getting a 4 in a die?
1 over 6.
Okay, 1 over 6. Why is it 1 over 6? How do you get 6?
Because there are 6 sides of a die.
Okay, there are 6 sides. Okay? And there are only 1 4 in that particular side. So you do have 1 over 6. So therefore, what is the answer?
1 over 12.
Okay, 1 over 12. Okay? So 1 over 12. So that is independent event. Meaning the two events can stand alone. Okay? Next, number 11. An urn contains 3 red balls, 2 blue balls, 5 white balls. A ball is selected and its color is noted. Then it is replaced. A second ball is selected and its color is noted. Find the probability of each of these. First and foremost, we need to identify, is it independent or dependent? Is it independent or dependent? There's the word replace, meaning,
Dependent.
okay, independent. Okay, independent. I repeat, number 11 is independent. An urn contains 3 red balls, 2 blue balls, and 5 white balls. A ball is selected and its color is noted. Then it replaces. Okay, a second ball is selected and its color noted. Find the probability of each of these. Letter A, selecting 2 blue balls. So how do we solve that? Selecting 2 blue balls. So what's the probability of selecting 2 blue balls? Okay, so the probability of getting 2 blue balls. Okay, so we have first ball and then the second. Okay, so your first selection, it should be blue balls. So how do we answer it? For the first selection, yung first ball we need to select, it should be 2 blue balls. So that will be 2 out of 10. Okay, the first ball that we need to select, that will be 2 out of 10. Why is it 2 out of 10? Ilan ba yung blue? How many blue?
Opo.
There are 2 blue balls, right? How many balls do we have?
10.
Okay, 10. So the first selection, okay, yung first ball na we need to select, it should be blue. That's the condition. So there are 2 blue balls over 10. Next, what about the second ball? The second ball is selected and its color noted. According to the first condition, a ball is selected and its color is noted, then it replaces. So meaning, after you select, you need to put it back. Okay, you need to put it back, replace. So that will be 2 out of 10 also. 2 out of 10 also. So therefore, what is the answer? What is the answer? The answer is 1 over 25. 1 over 25. How do you get 1 over 25? 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 Yung first selection, we need to select 2 blue balls over 10. Dapat daw yung first ball, blue. Eh, how many balls do we have na blue? 2. So, 2 over 10. And then yung second, kailangan blue ulit. Eh, there's a condition, you need to replace it. Okay? So, still 2 out of 10. So, if you multiply it, 2 tenths, multiply by 2 tenths, so that will become 1 over 25. Now, next, letter B. Selecting 1 blue ball and 1 white. Okay? Letter B. So, the probability that the first ball is blue, and then the second is white. So, the first ball is blue, and then the second is white. So, how do we answer that one? Yung first ball is blue. So, that will be 2 over 10, multiplied by, yung second ball naman is white. How many white? How many white? Okay, 5 out of 10. So, what will be the answer? What will be the answer? What will be the answer?
1 over 10.
Okay, 1 over 10. Okay, 1 over 10. Next, letter C. 1 red and then 1 blue. So the probability that the first ball is red and then the second is blue. So what is the probability that the first ball is red and then the second is blue? So how many red? Ilan daw yung pagpipilian na red balls? There are 3 red out of 10. Okay? So that's the first selection. Next, multiplied by the second, yung second ball, it should be blue. But how many blue balls do we have? Ilan ba yung blue? There are 2. Okay? 2 out of 10. So therefore, what is the answer? Therefore, what is the answer?
6 over 10 or 3 over 5.
Okay. The answer is?
6 over 100 or 3 over 50.
Okay, 3 over 50. Okay? 3 over 50. Okay? So that is independent. Okay? So you do have 3 over 50. So letter A, so we have 2 divided by 10. So there are 2 blue balls multiplied by 2 divided by 10 multiplied by 2 over 10. So you do have 1 over 25. Letter B, you do have 1 over 10. And then letter C, you do have 3 over 50. Okay? So number 11, that is independent events. Next, what about number 12? Approximately 9% of men have a type of color blindness that prevents them from distinguishing between red and green. If 3 men are selected at random, find the probability that all of them will have this type of red-green color blindness. So how do we answer number 12? Again, approximately 9% of men have a type of color blindness that prevents them from distinguishing between red and green. If 3 men are selected at random, find the probability that all of them will have this type of red-green color blindness. So how do we answer number 12? So we have 3 men. 1, 2, 3. Okay? So what is the probability that all of them will have this type of red-green color blindness? The problem says 9% of men have type color blindness. So 9%. So that would be 0.09. So meaning, that will be 0.09 multiplied by 0.09 multiplied by 0.09. The question is why? Why is it? Why do we need to multiply 0.09 3 times? Why is it? What's the reason behind that? So this is the first man, okay? First man, second, and then third. Okay? So the first man, what is the probability that the first of them will have this type of red-green color blindness? What's the probability? That the first man will have a red-green color blindness. What's the probability? What's the probability? According to the problem, what's the probability now? That the first man will have a red-green color blindness? 9%. Or that will be 0.09. Next, what about yung second man? Ano yung probability na makaka-occur din siya nung the same blindness?
9%.
Okay, 9% also. So that will be 0.09 also. What about the third man?
9%.
Okay, 9% also, or 0.09. Okay, so all of them, they will have the same type. So 0.09, 0.09, 0.09, because 9% of men have type of color blindness. Okay, so 0.09, 0.09, 0.09. So what will be the answer? Multiply. So what will be the answer? What will be the answer? What will be the answer?
0.00.
0.00. How many zeros?
3 zeros.
3 zeros. 7.
729.
Okay. 729. Okay. Yan. So that's the probability. Okay. Napakaliit. That's the probability that all of them will have this type of red-green color blindness. Okay. So that's independent events. Next, number 13. Okay. Insurance company or WWIC found that 53% of the residents of the city had homeowners insurance with the company. Okay? Of these clients, 27% also had automobile insurance with the company. If a resident is selected at random, find the probability that the resident has both homeowners and automobile insurance. Okay? So we need to look for the probability that the resident has both homeowners and automobile insurance with the same company, which is the WWIC. So what's the probability that the resident has both homeowners and automobile insurance with the same company? So that will be the probability of homeowners multiplied by the probability of automobile. So what will be the answer? So what will be the answer? What will be the answer? What will be the answer? So what's the probability that the residents of the city had homeowners insurance? That would be 53%. Okay? But these clients, 27% also had automobile insurance. In short, or in other words, that the probability of automobile insurance, meaning automobile insurance and also homeowners. That's the problem says, right? Homeowners at the same time, automobile insurance. Okay? So of these clients, 27 also had automobile insurance with the company. If the resident is selected at random, find the probability that the resident has both homeowners and automobile insurance. So that would be 53% multiplied by 27%. Because 27% also had automobile insurance. Okay? Also had automobile insurance. So that would be 0.53 multiplied by 0.27. So what would be the answer?
0.114.
Okay. 0.1431. Or 0.14. Okay, 0.14. Next, number 14. A box 1 contains 2 red balls and 1 blue ball. Okay? Box 2 contains 3 blue balls and 1 red ball. A coin is tossed. If it falls heads up, box 1 is selected and a ball is drawn. If it is falls tails up, box 2 is selected and a ball is drawn. Find the probability of selecting a red ball. Okay? So find the probability of selecting a red ball. So how do we answer that one? So find the probability of selecting the red ball. Okay? Let's try to analyze. A coin is tossed. O, tinos si coin. If it falls head up. Okay, so what's the probability that it will falls heads up? What's the probability?
1/2 po.
Okay, 1/2. Okay. Multiply it. If it's head, we need to choose box 1. Okay, we need to choose box 1. So what is the probability that if we choose box 1, the ball is red?
2/3 po.
Okay, 2/3. Okay, 2/3. Plus, next. Okay? Kasi either head or tail in selecting the box. So it should be plus. Kasi either. Although it's not given the problem, but the way we analyze it, either eh. Pwedeng mauna si tail or si head. So, or either tail or head or tail. So it should be add. Okay? It should be addition. Okay? Although it's not given the problem, but you need to analyze it eh. Okay? Sometimes you need to analyze the problem. Next. If it's tail, so what is the probability that if you flip a coin, it will be tail? So still, 1/2. Okay? So if it's tail, we need to select the second box. Okay? So if you draw a ball there, it should be red. But how many red in the second box?
1/4.
Okay, 1/4. So 1/4. So therefore, what is the answer? What is the answer? What is the answer? 1/2 multiplied by 2/3 plus 1/2 multiplied by 1/4. So what will be the answer? What will be the answer? Multiply then add. What will be the answer? Use your calculator. What will be the answer? The answer is?
5/8.
The answer is? Yes, the answer is?
5/8 po.
Sure?
Is it 11/24?
Sorry?
11/24 po.
11/24? 11/24? Okay, that's 11/24. Okay, 11/24. It's very good. Okay, 11/24.